Hello, my name is Krista, and today we will working again with the calculate with complex number. Now I have another complex number which is z is equal 1 plus I multiplied by square root of 3. So now we will try to identify which is the real part of this complex number and which is the imaginary part of this complex number. Okay, so let me see. The real part of this complex number here is 1. And I'm sorry. So and we have a imaginary part of z is equal to square root of 3 multiplied by I. Well, let me do that like this. So the real part is 1 and imaginary part is square root of 3 multiplied by I. Okay, so this we've done now. So now we should draw the complex number in an Argand diagram. I'm sorry, this one is something wrong. So now I will do that in GeoGebra. It's a very good program. I think that you should try to learn this. And now I will put this variable here, this complex number, in the input panel here. I will write z 1 is equal, just a moment, so something like that, 1 plus I can take here keyboard. I'd like to have this keyboard so I can write the square root of 3. Oh, no, disappeared. Oh, I'm sorry. Okay. So we should write, yes, square root of 3 and enter. So now the GeoGebra have a sketch of this complex number for me in the complex plane. This is the complex plane. Let us now change the axis first of this complex plane. We go to the graphics, and after that we take x-axis. We put the label here, the real part of this complex number, z. And after that we should take the distances here. I will put 1. And in the imaginary axis, I will put em imaginary z. Okay, and the distance will be again 1. Okay, so now I have the real axis and imaginary axis. See, so I manipulate that with the middle point. I'm rolling forward and back. So now let me put a vector here. I will, I'm sorry, I should close the phone. I must close the phone. I'm sorry for that. That distracted me. Okay, So now we will sketch this vector, and I will go to the object properties. I will change the thickness. Let me see, is the very big, so something like that. It's okay. Take me again object properties for the basics. I'd like to put the name and value. So, okay. Good. Let me delete this point. I don't need that. So now you see that this u is 1. I'd like to change it in polar coordinate to have this length here of this vector is 2, and the angle theta or alpha will be 60 degrees. Okay, so now let me put one perpendicular line here from this point to this axis here, the real axis z, and I will put a point, and this point will be here. So now I have at this point, so now I will find the angle, and the angle is 60 degrees. Okay, so let me now manipulate this angle here. I go to the object properties, style, and I will put this one here to 2, the thickness, and I will put the 100% here and 100% here. Okay, so let me change this alpha now to theta, and okay, view the keyboard. I'd like to find so now I don't know. Here is the theta. Okay, and I will delete this alpha. Okay, let me see if they changed, and they changed. Now we have a theta. Let me take option here. I'd like to take 32 font size. So, good. So now we have a 60 degree here. Here is the 90 degree. Let me sketch one polygon here. So, and so, okay. So, this is the B, this is the C. Okay, so I don't need this one. This is the C. Oh, they are changed now. They changed the equation. They changed the equation. You know, they don't work where I can go back. Okay, I must delete this one. Yeah, I'm sorry for that. So, and I will change the equation. The equation here is 1 plus from 3 Okay, and multiplied by I. So let me see if it's okay now. Yes, it is. The square root. Okay. This length now is 2. This length is 1, and this length is square root from 3. And let me do again the same. Now a polygon. Okay. So this one I don't need. This I need. So okay. And the C I don't need. Oh. Okay. Again the same. So okay, so now I'd like to copy this one here. I hit the print screen and I will mark these windows and I will go to the paint, Control V. So now I will select these windows here. I will take these windows, I will crop this, Control A, Control C. I will go back to my Word documents and I will put this picture here. So now I have a beautiful picture here. I will right click, season position. I will take 30%. I will take OK. Let me see now what happened. Okay, so now I must take the height here. So something like that. It's okay. So this is the Argand diagram here in the complex plane. So now let me see if we can calculate it with the help of this picture. How big is the absolute value of this one here? Okay. So now we take the absolute value of Z is the U is the equal to U and is equal to absolute value from sorry, absolute value from this here. I'd like to copy this one, Control to skip to write 2 times. Okay, and this one is equal. When you have something like that, we write the square root from 1 square root 2 plus we have a let me write like this, square root from 3 and the square root of 2. Okay, and this one is nothing more than square root from 1 is 1 and square root from 3 power 2 is the 1 plus 3 is the square root from 4, and this gives the 2. Okay, so this length here is 2, and we see that in polar coordinates that this is 2, this is 1, and this one is square root of 3 because How could we calculate this one? Let me calculate this one too. So we can say that how we get the square root of 3. This is the Pythagorean theorem. And the Pythagorean theorem saying that if we have a square root of 1 squared, just a moment, we have a first hypotenusis, which is 2 square root 2 minus 1 square root 2, which gives square root of 2 power 3 is the 4 minus 1, and this gives the square root of 3. Okay, so now we have a calculate this one. So this here is the square root of 3. So you know that how people doing that. Okay, so and square root of 3 is the 1 that 73, something like that. Okay, so now let us to find the conjugate of this complex number. So the conjugate of this complex number is, so let me take this one here, and we take a conjugate for this. Is there nothing more than 1 minus I square root of 3. Okay. So if I like to ask Wolfram alpha, so I must write conjugate. Let me do that. Control C here. I will put here from 1 plus square from 3. Let us ask Wolfram alpha. I have a up, so I don't need to start. So I must wait in a little bit. I have a slowly computer. It's time to buy a new one. So let's see what Wolfram should say. Square root of 3. What's the problem? Something is problem. I don't know what's the problem. Maybe. Let me say again. Okay. They don't function. Let's ask from here. Let me see. Fill in Wolfram alpha. I see. And ask. Maybe okay, so now we have here 1 minus square root of 3. I'm sorry for that don't function. But now you see that this is right. Okay, So we close this one here. So this is right. So now we will find the argument of this complex number. So the argument z is theta, which is equal r tangent from from square root of 3 divided by 1 tangent, which is the same like tangent square root minus 1. You have that in your calculator. Square root of 3, because square root divided by 1 is square root of 3. And this gives us, if you put in your calculator, 60 degree, or this is the same, 60 degree, 60 degree multiplied by pi and divided by 180 degree. Let me see what should we get. And this gives pi divided by 3. So this angle here is 60 degree of pi divided by 3. So this is very good now when we can use in the Euler formula. Okay, so now we have found the angle. I don't know what's the problem with the color. So I must find what's the problem with that. So, okay. So now we have coming to the Euler formula. Let me see if get a function like, okay. Theta equal to that. And this is something. So here is the argument. So now we have coming to the Euler formula. Okay. And the Euler formula is z equal, and we have the absolute value here is the 2 multiplied by h, I multiplied by pi divided by 3. This is the Euler formula. Okay? So now, if you like to show this Euler formula in polar coordinates, you must do that like this. Z is equal, the first we have a U, which is 2 multiplied by cosine pi divided by 3 plus I sine Control G pi divided by 3. And now if you put in your calculator, take your calculator and take this one here and multiply this one 2 and this one here 2 sine. So we should get the first one. If you take your calculator, but you must put in the radian, so you must do the settings in your calculator in radian, and after that we can write 2 multiplied by cosine pi divided by 3, and I receive 1 plus E multiplied, when I multiply 2 by sine, and I get square root from 3, but before so I have a coming back in this formula. So I have a coming back with this formula here in this. This is the equal like this. So now we're done. Everything is okay. You have this complex number here. I hope that this help you. So remember, the argument is the square root here divided by 1 here. So that's it. So put some comments if you like this video. Next time I will put another exercises. So these exercises will be next time will be z equal square root from 3 plus I. So try to solve this one by own, and after that I will solve this problem and see if you do it like me. So now if I like to control if I did right everything, I should ask the Wolfram alpha, so we can control this. So let me see what Wolfram alpha shows. Cancel Wolfram alpha. Okay, they are saying that R is the U here, and this is the 2, and the angle here is the 60° of pi third. So we've done. This is okay. So finally, I'd like to say that I hope that you like this video, and if you like, you can subscribe and give the comments. Maybe you see that I have a little problem in my English. I don't live in the United States. If I live in the United States, I should speak perfectly English, but I'm trying to do my best because I'm a hard worker. Thank you very much. Have a nice time and good luck to you. And welcome back.